we've been looking at the area of different shapes. We're going to talk about two different types of things: regular polygons, and then we're also going to look at composite figures. So when we are looking at today's lessons, those are the two things that we're going to be talking about. So first of all, we'll talk about the areas of regular polygons and then the areas of composite figures. So we have a few things that we want to talk about. The center of a regular polygon is the center point that is the same distance from all the vertexes. So then the radius would be from the center to the vertex. And the apothem is the height, or it is perpendicular from the center to the side. And then the central angle is the angle that is formed with the two radii put together for the vertex and the apothem, or the regular angles of each inside of from the center. And then a composite figure has two different shapes or more shapes. It's composed of many shapes or different shapes. So in the figure, pentagon PQRST is inscribed in circle X. So we have this pentagon, and we're going to identify the center, a radius, apothem, and a central angle of the polygon, and then find the measure of the central angle. So we would have our center here would be X, the point X. Our radius, there's a few, but XQ or XR would be radii. And then the apothem is this XN that is perpendicular to the side. And the central angle is going to be the 360 divided by 5 because it has 5 sides. So 72 degrees. All right, so this is important so that we can use then, if this is a regular polygon, so all the sides are equal, then what will happen is these angles here will be split in half, and we can use trigonometry to find this height here or a missing side, whichever one we don't have. So those are just identifying some of the parts, and then let's look at actually finding the area. So you can go through this, try this, pause the video, try some of these problems, and then check to see if you get the right answer. All right, so the top of the table is a regular hexagon with a side length of 3 feet. So that means each side is 3 feet. And an apothem of 1.7 feet. So that's this height here is 1.7 feet. What is the area of the tabletop to the nearest tenth? So if you notice, we have this triangle right here. So if I find the area of that triangle, which a triangle is 1/2 base, which would be 3, times height 1.7. And we have 1, 2, 3, 4, 5, 6 of those triangles, so I'm going to multiply that by 6. So I get 15.3 feet squared. So what you can think of is like if I found this, if I found this perimeter of this here, that would give me the 6 times 3, which is this part, and then we have the apothem. So the area of a polygon is 1/2 perimeter times apothem, because this gives me the area of all the triangles all together. So again, try this one, pause the video again, best if you can try to work it out, and then check your answer. Should have gotten 9 feet squared. So that's how we get that formula, the area of a regular polygon. So all the sides have to be equal is 1/2 the apothem, which is. So let's look at one here. Since this side here is 5, that makes all of these sides 5. So my perimeter is 5 times 6, because there's 6 sides, or 30. So we have that. We need this apothem length. So my central angle right here is 360 divided by 6, because there's 6 sides, so I get 60. And this angle then right here, each side here would be 30 degrees. So I have this 30, 60, 90, and this half would be 2.5. So if you remember, this is your short side and this is your long side. So your long side is your short side times the square root of 3 on a 30, 60, 90. So 2.5 square root of 3, which is see if I can, square root of 3 times 2.5 is 4.3. So my apothem is 4.3. And another way you could do that is, let's say I use my 30, 60, 90. Again, I know this is 2.5 and this is 30, and I'm looking for this. So opposite over adjacent is tangent. So tangent 30 equals 2.5 over x. And so x equals 2.5 divided by tangent 30. And that should also give you 4.3. So there's my apothem. So my area equals 1/2 my perimeter 30 times 4.3. So a few ways you can get that. And you should get 64.95 meters squared. So try that again on this next one. See if you get the same thing, or see what you get here. Doing those same type of methods. Here we have your radius. So you're going to have to find the area of the regular polygon. So we are going to take 360 divided by 5 in this case, so we get 72. And if I divide that by 2, that's 36. So this angle is 36. I'm going to need this side, and so the apothem, and I also need this side length. So I'm going to have to, this whole side length. So I'm going to have to use a little bit of trigonometry. I have the hypotenuse, and I need the height, or this adjacent side. So I can go cosine 36 equals adjacent over hypotenuse. So 9 times the cosine of 36 should give me this apothem. So my apothem gives me 7.3. And then to find my side, I can either use Pythagorean theorem or sine. So sine 36 equals opposite x over 9. And then multiply both sides by 9. So 9 sine 36 is 5.2, and I'm going to multiply that by 2, or 5.3, and I'm going to multiply that by 2 to get this whole side. So here is 5.3, so this whole side would be 10.6. So my perimeter equals 10.6 times 5, 52.9, and my area then is 1/2 perimeter 52.9 times my apothem 7.3. And I get 193.1 centimeters squared. So those are just some ways using that trigonometry to find those missing sides, and a little bit with the central angle. So that is the area of your polygon. The next thing we're going to talk about is the area of composite shapes. Again, you would want to pause the video, try these, see if you can get that same answer. So area of composite shapes means I'm going to have to find the area of each of these shapes. So I can see a few shapes here. I have a rectangle here, or parallelogram. I have a triangle here, and then I have 2 half circles, which together would make 1 half circle. So I'm going to find each thing. So the area of your rectangle would be this is 16 times 32. So 512. The area of the triangle, which would be this part, this triangle here, would be 1/2 base, so 15 times 32. So 1/2, 15 times 32. Which gives you 240. All right, so that's my triangle, and then we have the circle when I put the 2 half circles together, which equals pi r squared, and my radius is 8 because my diameter is 16. So I'm going to go 64 times pi, 201.1. And so then you just add those together. So the 201.1 plus 240 plus 512, and we get 953.1 feet squared. So all of these shapes you have, you're just going to have to take them each piece by piece and then find their area. So that is the area of regular polygons and composite figures.